So it's Plasma X3Z, and I'm doing part 2 of my midnight attack theory. So, anyways, I did some math, some calculating math, and it's more for the slope of midnight. So I got a pretty badly drawn slope thing there. Which, the bottom here, the length of it is 35 millimeters. The height from there to there, because this part down there doesn't really count, but the height from this line there to there, that is 7 millimeters. The whole height from there to there is 10 millimeters. So the slope is 36 to 37 millimeters high. So that's kind of that. It's not that big. The angle of the slope, I couldn't get the angle with this tool thing because it's just too difficult for me to do. So I use a graph kind of style of doing slope. So it's got a 1/5 slope if it was on a graph. Now, I compared midnight to storm. Now, I think, yeah, so I'm just going to say a little bit about it. The length of the slopes are similar length. This one has 3, this one having 2. The difference is that midnight has 15 millimeters here, allowing it to lift the thing, where this only has 5. Giving very little room, which basically makes it impossible for storm to lift up. So that's one of the advantages midnight has, though it's lower weight. The one thing that I found interesting is I was looking at 100 and flat. I was doing a height with 100 and flat, and I noticed that when you put the metal wheel on here, that the metal wheel sinks down by about 5 millimeters of 100. So really, your metal wheel starts at the bottom part of the metal wheel is at 95 millimeters high without flat. Flat is extra 10 millimeters, so it's at 105 millimeters height here. And this slope starts here, putting this slope at 110 millimeters off the ground. YD, let me just show you the height of everything. Flat and YD are both 10 millimeters. 100, 10 millimeters, 145 is 14.5 millimeters, but I'm going to go put it as 15 millimeters to round things up. Makes it easier for me. So, with these together, you got 160 millimeters. Here's an extra 10. And then Earth goes down by 5. So, wait. I think I screwed up. Yeah, I did. It put it at 20 millimeters high. 20 millimeters. But 5 puts it down by, since Earth sinks down, and the level would be, it's at this level. So it's -5 from here to here. Because this here is basically here to top is almost 15. Here, that bar there to there is 5. You can't really see that well, but there. So that's 5 millimeters. So 5 millimeters plus 10 millimeters so it goes -5. So ultimately, this is sitting at 15. So if you look at it, see, it's better if it's on something hard. The lowest point of Earth, the underside of Earth, is just under 15 millimeters in height. Let me just zoom in a bit. You can see better. So that's kind of boring too, most likely. We have 15 millimeters in height. So don't look at the top here, look at the bottom part of Earth. After that, I did midnight, and like I said, the metal wheel goes down by 5, so this would be at 5 millimeters, but plus 10, so that's 15 millimeters. But how do I do this math again? Anyways, the slope starts just under 15 millimeters. So that puts the slope exactly, let me just show you here, right under Earth. Allow me to lift it up, which is good, because it's just low enough for this to work, but without this coming into contact a lot. So that's a pretty good key factor of that. So yeah, that's what I've been doing. It's pretty lame to sit there and do it. But yeah, it took a while. There you go. It's kind of a bit of height difference. It was a bit confusing. I can maybe ask me and I could try give you my my sheets about it. Anyways, yeah, so I guess I could draw a bit more. Anyways, yeah, that's it. Next part will be the theory in action. So, see you then.